Okay, so welcome everybody. Thank you for joining. Before we get going, I'm just going to quickly introduce HECAP, the HECAP Plus initiative. So ultimately, this is the first of hopefully many seminars that have been initially organized by the HECAP Plus initiative. And what we are is basically an initiative that has been developed to support and promote international and interdisciplinary efforts that will empower the adoption of environmentally sustainable practices in basic research. So please feel free to find out more about us on our website at www.hecap.eco. But without further ado, I would like to introduce our speaker, who has kindly agreed to talk to us today about all the work that's going on with the FCCEE. So I guess, yeah, without further ado, I'd like to introduce Johannes Gutleber, who's going to talk to us today about the future circular collider environmental aspects. Thank you. Please go ahead.
Okay, thank you very much, Hannah. Good afternoon to everybody. Let's see if Hannah, are the slides in full screen now? Is it okay? Can you see them? Okay, so thanks for the invitation to share with you some insight in the activities on the environmental aspects of the future circular collider. I have put, in addition to my name on the first slide, the name of my colleague, Patricia Laiduni, who has taken over with the beginning of the year the full management of the environmental impact studies of the future circular collider. So if you have any particular technical questions after the seminar, please also feel free to contact either me or her or both of us by email, because she's probably more into the technical details than I am. I am keeping more a high-level view on the overall sustainability of the FCC, make this a research infrastructure that is sustainable from environmental, societal, and economic perspectives. So with that, we can start, actually, and go into the subject matter. So this is a little bit the program for this afternoon. I will spend some time on terms and definitions, the challenges that we have for the environmental analysis of the FCC working methodology, territorial approaches, where we are with our field investigations, how we are doing with stakeholder engagement, which is an important part also of environmental evaluation, the documentation of all of the studies that we're carrying out, and provide you with some summary conclusions and outlook what is next. For me, it's very important to share with you the terminology so that we're all on the same page, what we mean, for instance, by environment. Environment, according to the French legislation and the one that is also applicable to us at CERN in Switzerland, encompasses really everything into which the project is embedded. So this is not limited to the biosphere, so typically fauna and flora aspects, or maybe climate and air, but it also encompasses population, human health, socioeconomic aspects, material goods. So there is the whole body, the entire environment is to be regarded in a holistic view. And in terms of sustainability, we always look at the three dimensions together. That is the biosphere ecology, the society, and the economy. These three fundamental pillars of sustainability, if we try to optimize a project, are very frequently in competition with each other. So this is really the challenge, to be able to make sure that we have a research infrastructure that is societally acceptable, that can fulfill the science needs, and that is also compatible with the environment. To be able to do that, we borrow methodologies and tools from economics. Economics is a social science discipline where we analyze benefits and positive externalities, and also cost and negative externalities, and in quantitative terms, and we bring them together, we subtract one from the other, and we see if the overall value of the program or project is still positive, and it allows us to understand where do we have drivers and where we can further optimize the project. At that point in time, I would like to introduce also the terminology of weak and strong sustainability, which is very important when we look at this cost-benefit approach. Weak sustainability is based on the assumption that all kinds of capitals are substitutable, and especially natural capital is also substitutable. So for instance, you can cut down a hectare of forest and compensate this loss of the 1 hectare of forest, maybe with some economic benefits or with some training benefits. So this is a classical cost-benefit approach, but unfortunately, this is an approach that leads in the end to I would say rather a degradation, an unavoidable degradation of the biosphere. So on the other hand, what we have is strong sustainability that claims that certain parts are simply not substitutable. Certain capitals, especially natural capitals, are non-substitutable, and we have to find other ways. That does not mean that we cannot compensate for it, but we have to be sure in which ways we are compensating it. For instance, the loss of 1 hectare of forest can be sometimes compensated with the replanting of 2 or 3 hectares of forest, or with the forest of a different and a quality that is maybe adapted more to the climate change. I have given you a reference to this concept of weak versus strong sustainability. It's a rather famous author that has coined this concept, Eric Neumeyer, and he has recently published an open access book on this, which I can only strongly recommend. Talking about the project, it's very important before starting with environmental evaluation to define the scope of the project, to figure out where are the boundaries. So the project by itself is any intervention in the natural space. So then we have to see what are all the aspects, what are all the elements of the project that can interact with this environment. And that for the Future Circular Collider is not just the research infrastructure. It's not the subsurface only. It's not the surface sites. It includes, of course, also the particle accelerators and the experiment detectors, but it includes also territorial developments. May that be electricity lines, may that be water lines, water treatment plants, ways to revalorize or reuse excavated materials, housing, also workshops, laboratories, transport. So it's really a very, very long list that is to be regarded. Now, to be able to build actually a Future Circular Collider, it is not sufficient simply to have the funding and to take a decision to say, I would like to construct that. You need the permits. And the way to the permit in France and in Switzerland is a process that is called the environmental authorization. So that is a rather lengthy and all-inclusive process which regards different aspects of the environment of the project for which a scope had to be defined, and evaluates these different aspects. And in the end, the authorities give back recommendations either to further improve the project or to accept it or to reject it. So in the end, to construct an FCC, one needs to have this environmental authorization in both of the countries, so in both in France and in Switzerland. The methodologies and the approaches are different in France and in Switzerland. This is something that is a challenge for the Future Circular Collider because it straddles across the border. It goes also a little bit under the League Geneva. In Switzerland, it touches the canton of Geneva. In France, it touches the departments of Haute-Savoie and Ain. So this is why it's a rather lengthy and rather, I would say, challenging process. And we have started this process recently with the authorities and defining also the individual steps and methodologies on how to advance on those. So here is just a screenshot of the legal basis in France and in Switzerland. Maybe to point out that over the last 6 years, we have been working at CERN with the Swiss authorities on an update of the so-called law for the encouragement of research and innovation that permits now developments, future developments at CERN that have a territorial development need to be lifted to the federal level to get out of the cantonal level. Because Switzerland is a confederation, and in many cases, the cantonal laws are stronger than the federal laws, but this would potentially be prohibitive for a new project. So this is why this update of the law over several years has been carried out and voted now, so to permit CERN to have a level to obtain an authorization at the national level equivalent to the national level authorization that is already, for which a process exists in France. So now, if we look at the environmental evaluation, that means evaluating the potential impacts, we need to decompose the process. We need first to understand in the project what are so-called environmental aspects or items. Those are all elements in the project that potentially can interact with the environment. Then on the other side, we need to make an analysis of the environmental stakes or issues. I'm not sure if the English translation here is the good one. The French one is called enjeu. The French term is called enjeu, which is kind of like potentially environmental valuable elements. And then actually we can cross the environmental aspects that have potential effects on the environment with the environmental stakes. I have an example here. If you have a wetland and you would like to build a wind farm, then you know that the wind, you can understand that the environmental aspect of the wind farms are maybe the visibility or the noise. If you build it in a desert, probably the environmental impact is completely different than in our wetlands. So only when you understand that you have your wetlands and you cross that with the wind parks, only then you can really understand what are the potential environmental impacts, what is the likelihood of occurrence, what is the severity for this to occur. So this is an approach that is codified actually in an international standards. It's the EN ISO 14001 norm. So for the Future Circular Collider, we take this as a baseline. That does not mean that we are 100% compliant or certified with that ISO norm, but we take that norm and we work according to it. Behind it is this concept of environmental risk management. So you analyze the environmental stakes where you embed, into which you embed your project. You analyze the environmental aspects, you cross them, you get a risk matrix out of it, and you see where in the risk matrix you fall with the different combinations and in how far you have to take care of planning and implementing, avoid, reduce, and compensate measures. This is a documentation that in the end will have to be delivered in one way or the other, maybe in database, tabular form, or in a descriptive form. But this shows to the authority that an effort has taken place to understand what are the impacts, what are the effects, and then iteratively and gradually reduce it to a way such that the authorities grant this authority for permitting the process. The current state of these developments here in January 2026 is that we have analyzed about 3/4 of the environmental stakes and issues in which the project would have to be embedded. So it's always localized. We cannot really do that in a generic way. We have to be geolocalized by doing that. We have analyzed about 1/3 of the environmental aspects and effects. The challenge here is that not everything in the project is already well defined. For instance, particle accelerators and experiments will be defined only later at the stage. So for the time being, the very specific environmental aspects are more more known for the civil works, for instance, or for certain infrastructures. And we have only recently started to analyze the potential environmental impacts. So only very few of those have been done. And the real activity will take place with external consultancy companies from 2027 onwards into the future. So this analysis is a process which is called environmental impact assessment, out of which an environmental impact study has to be delivered in the two countries, and there it is still to be defined if this environmental impact reporting can be done in a harmonized way. So that means the same documentation in the two countries, or if two individual documentation sets will have to be produced. Preliminary discussions with the environmental authorities in the two countries point rather to a harmonized approach of the reporting of the environmental impacts. It is simply easier for them. The authorities do not very much appreciate if they get a few tens of thousands of pages, literally, of documentation in the two different countries, because then afterwards the two countries need to exchange this documentation. This is a requirement of the so-called ESPO agreement. In case a transnational project or a project with transnational potential impacts is taking place, the two countries, in this case not CERN, but the two countries, France and Switzerland, need to inform each other about the impacts, and they need to accept them or ask the project owner to further mitigate them. So this points actually more to the advantage of a harmonized approach. In addition, The Aarhus Agreement, the Aarhus Convention that the two countries also signed in, requires that the population is informed and to a certain extent also engaged in the environmental evaluation process of the project and the optimization of the project. And also here a harmonized approach is something that is more favorable. In France, the public information and engagement process is formalized. This is called the so-called débat public, which is a public consultation process. We are going to start that now in late spring 2026. And the first formal phase will take until autumn, and then a continuous accompanying phase will take place until a project is authorized and also constructed. In Switzerland, there is not a formal legal process that is required, but it has to be carried out nevertheless in phase and in synchronization with the French process. So again, a harmonized approach is something that is more appreciated. There are some conditions to be able to enter into an environmental impact assessment phase. That means the processes and the methodology with the both host states have to be agreed. This is done in a process which is called le cadrage préalable in the two countries. So this is something that will be engaged now in springtime 2026. The project scope and parameter need to be agreed because we need to understand where are the boundaries, what is in and what is not regarded. We need some documented designs, mainly for the civil engineering and the construction process, because this is currently the main preoccupation of the population and the elected representatives of the people, because it is the most visible part. The construction is supposed to take in the order of almost 10 years. So this is where the massive amount of visible activity is really taking place. So we need to speed up here on getting more on detailed designs. For other aspects, it is acceptable to have requirements and constraints and envelopes defined. This is something that in the French legal framework is foreseen. If you do not have a detailed design already for the infrastructures, you can work with voluntary commitments and taking care of making environmental impact assessments with margins and uncertainties, assuring that your impacts will be not higher than something. So you have to really know your requirements and your constraints so that you can have the envelopes. I mentioned already beforehand, however, that one of the major challenges that the different segments of the process of the project or the program are defined with different speeds at different points in time. So while, for instance, today we are in the process of designing the subsurface structures, the surface sites are today not at all designed, and we must actually also not immediately impose surface site designs, because this is something where the public engagement is important, and we need to first collect the feedback from the public. What are their invariants? What are their worries? What are their constraints? What are their requirements? On the other side, the particle accelerator design is only starting now. Technical infrastructure design is a little bit more advanced, but clearly not yet full up to speed also. And experiment detector design is something that comes potentially even later. Today in the FCC, the colleagues are working on a generic detector concept. So this is something that can, however, be used for an environmental impact assessment if envelopes can be defined based on this approach. But clearly at a later stage, updates of the environmental impact assessments will have to be delivered to the authorities, and they will have to be gradually reapproved afterwards. So the approach taken for the FCC is that we are engaging now this so-called cadrage préalable phase, where we agree on the scope, on the processes, where we gain also a mutual understanding with the authorities that not all of the elements are defined at the same level, that we get a mutual understanding to which level the different environmental analysis and studies have to be carried out, define phases, deliverables, milestones, constraints, also resources, because we will have to work mainly with external companies to carry out these works, and also estimate scheduling costs for this. Overall, the optimization of the process is again framed in a regulatory rule set. In France, this is called éviter, réduire, compenser, avoid, reduce, and compensate. Here it means where the environmental stakes are so high that they are unacceptable, we must adapt our project to avoid an effect on these stakes. where we cannot adapt our project because otherwise we would not be able to implement our project, there is a certain limitation to enter some areas where environmental stakes take place, but we need to adapt our project nevertheless to it. And for residual impacts, we will also have to have compensation measures to be able to reach in the end an overall project that is neutral with respect to the environmental effects. And here I come back to what I mentioned originally, to the concept of weak versus strong sustainability. It is extremely important to agree with the authorities which of the capitals, of the natural or human capitals or assets are substitutable and which are not substitutable, because this determines what kind of compensation measures are permitted. For instance, in Switzerland, it is not permitted to implement a collective compensation for the loss of protected agricultural land. Here one has to compensate at minimum 1-to-1, if not higher, whereas in France, for instance, the legal framework permits a collective compensation. That means if we really cannot avoid a protected agricultural space, the project could also work on complementary compensations, for instance, providing clean water for irrigation purposes to nearby fields that suffer from drought in the summer. So there are really an avoid reduce compensation plan for the FCC will have to be developed over the next few years. The concept of avoid, reduce, and compensate is also applicable in Switzerland, just that they add actually a fourth stage to it, which is called the amelioration, so the continuous improvement. Continuous brings us to the next slide. This whole process is not a one-shot activity. It is an iterative process. One analyzes the environment around the project. One listens to the people, engage with the people, bring this into an analysis of the environmental effects and aspects of the project, see if adaptation has to be done, then adjust, and then actually we turn over and we improve the project actually continuously. So personally, from the beginning onwards, I was demonstrating this always with this balancing of a triangle on the finger, where on the one side I have as a high requirement for my research infrastructure that I have to provide a high performance. I call this scientific excellence, because only if I have a particle collider that is able to attract a worldwide community of, let's say, 10, 12,000 researchers, I will be able to justify that investment to my stakeholders. On the other side, I need a social license to operate. I need a territorial compatibility. And on the third side, I need also to understand that my risks to implement the project need to be respected, and that I have also cost limitations, because of course with endless cost I can satisfy always my scientific excellence and I can do everything for my territory maybe, but our costs are, so our budgets, let's put it like that, are also finite. So this is another capital aspect that we have to consider in our sustainability equation. So here I gave you just a list maybe afterwards to look where we are with the different aspects, what is in work, what we have started to analyze. But I think for the presentation here, we can skip over that. The importance is that all this process leads here to a prioritization of tasks. We cannot jump in and do everything at the same time. We need to do some things first and other things second. And the first thing that we were focusing was the layout and the placement of the infrastructure, to define also an environmental taxonomy that permitted us to prioritize and categorize the different environmental stakes or issues, and then to work systematically through the environmental aspects. There were some invariants that we had to respect, especially from the research infrastructure perspective, from the particle accelerator perspective. I knew that, for instance, that I had to have a straight section at the interaction points which could not be smaller than 1,400 meters, because I had some beam focusing constraints that I had to respect. I knew that technical sections couldn't be smaller than 2,000 meters because I have to fit in the radio frequency cavities of a certain technology for the acceleration. There is some shaft depth limitations that I could not exceed because we did some pre-studies and we figured out what is technically feasible today and then the next 10 to 15 years to come. There are some constraints that come in also from optics designs, from RF system point of view. There are constraints on the placement with respect to linking the FCC to the injector complex at the CERN Previsor site, the SPS tunnel, for instance, and so forth. So this all had to be put into the equation. On the other side, from the environmental stakes point of view, we standardized actually the categorization into 4 different levels, where we had one that was intolerable, like an area that because of a combination of surface and subsurface constraints was absolutely a no-go area and had to be avoided. Others where the environmental stakes were strong, but if the project would have not been possible, if I hadn't the possibility to go there, we colored it orange and we said, good, we can go there, but we will have to make reduction and compensation measures and other areas where it was possible with minor adjustments to go. Here I give you here a list of all of the different aspects that we took into consideration. So just to give an idea, in the end, it was a combination of about 100 different layers in the geographical information system that we had to consider. Give an example for absolute no-go areas was that we have, for instance, an environmental protection zone Natura 2000, or we had groundwater protection zones, or we had conflicts with existing railway networks. So these are kind of things where we say we do not even try to go there and make a modification. We will never succeed. Other areas where the constraints were very strong, but where we thought it would be justified to make an adaptation of the project or to work on the reduction and compensation measures was, for instance, bird protection areas, sensitive subsurface waters where we could maybe with certain drilling technologies mitigate the risks, flood hazard zones where we knew that with civil engineering technologies we can master the technologies or some polluted soils. And then the other, the yellow zones had less requirements. So this led us to a constraint-based scenario development. I give 2 examples here, geological and topographical on the left, and this, what we call it, the sensitivity grid. So the coloring of all these about 120 plus layers that showed us in the area where we are, where we could go and where we could absolutely not go in across the 2 countries. We have to understand, of course, that the requirements and the constraints are not the same in France and in Switzerland. So a red in France does not have the same condition as a red in Switzerland, for instance. So this had to be agreed also with the host state authorities during the work beforehand. I give some other examples of layers that we considered is for instance, territorial and urbanizing planning zones, biodiversity indexes, or selected topics like zones that are classified as environmental protection zones, or already road projects which are already under planning and which could have not cancelled anymore. Some particular constraint that I would like to point out again is the protected agricultural spaces. In Switzerland, they are called surface d'assolement, SDA. And there exists a national plan for them, a quota for each canton, and the canton is not allowed to exceed this quota. So this is a particular constraint in the canton of Geneva, and this had to be also resolved in negotiations with the canton and with the confederations, because in the end, we will touch also this protected agricultural space, and it will have to be also compensated, and we had to understand if at all this was possible. Typically, this would have been a strict no-go area, but we succeeded to negotiate that we can enter that. So this is again an example of this iterative approach. For instance, here for the placement that took place, each of placement scenario was evaluated according to a multi-criteria analysis. We figured out, is it to be discarded totally, or can it maybe further develop into a potential feasible scenario? If yes, then we went on, we made modifications on the beam optics, we made displacements, we made adjustments, and we iterated until either we again had to discard the scenario and develop a new class of scenario, or actually to consider it for a final evaluation. And in the end, actually using a multi-criteria analysis of about 37 different stakes that we adopted from the UNIDO for industrial plant localization, we were able to figure out a certain reference scenario that was actually feasible. Here is again a view on how we made these territorial, let's call it ranking or prioritization of the performance of a certain layout and placement scenario. I split this into three big pillars, the different criteria. One is the territorial compatibility, again, the scientific value, and the implementation risk and cost. And like in an energy scale, efficiency scale, I showed to the authorities the performance of a certain scenario, and that helped us in the end to perform a ranking of the different scenarios. We use an algorithm which is called VCore here, where you can actually combine aspects or multi-criteria with different units, and you can optimize positively to optimize, or you can also minimize, so you get a ranking. And when you do that, you can have your different scenarios and you can rank them according to their performance, according to the multi-criteria analysis and the individual pillars. So in the end, it was 100 different scenarios that I developed and that we have collectively, also involving the authorities on a selected basis, analyzed. And in the end, we found one scenario that is the famous 91-kilometer circular scenario with 8 surface sites. That was found to be the most suitable one. It had a good scientific, or has a good scientific performance for both accelerators. That was another challenge, because I had to integrate the lepton collider and the hadron collider requirements. That has a better territorial performance than the other scenarios, and that optimized, that permitted also optimize in terms of subsurface placement. So 8 surface sites for this scenario. A site PA that is in France in the Department 1, very close to an existing LHC surface site, that is the LHCb experiment site in Ferney-Voltaire. A surface site B, it's a technical site in Pressange in Switzerland, and the experimental surface site D, and the technical site F, G, H, and J, again in France in the Department of Haute-Savoie, then crossing actually the Rhône River and having another technical surface site PL here in France in the Department of Ain. So yeah, this is documented also. This documentation of the methodology of the invariants and the results has been provided to the French and the Swiss authorities for review. So this is why this is a version document. So today we are in the version 4.0. This is the last, incorporating the last feedback from the authorities that permitted us then to present the scenario to the European strategy for particle physics update. Stakeholder management is an important aspect in this. So this is why we developed a whole toolkit for the engagement with the public in French language also. So a website, a managed email address with a ticket system behind it, so that we can dispatch questions to the specific domain experts. I should say that in France, at least the public engagement up to a certain level is required. So it's not sufficient to inform people, or we also have to consult the people. But for the FCC, actually, we decided, addressing ourselves to an organism in France, which is called La Commission Nationale du Débat Public, the National Commission for Public Consultation, to give a recommendation to us. And they said actually that as much as possible we should go into a co-decision regime, which is however not really possible in all aspects, because that would have meant too much engagement of the public in technical aspects. But a consultation, at least for the placement, for the surface side, for the construction related aspects, this is something that the CNDP really encouraged us to do, and this is the level of public engagement in the FCC that is also taking place. So that toolkit is then not limited only to the web page, but we also provide interactive maps where the people can explore actually some details also about the project, for instance, also the territorial sensitivity grid. They get an understanding also why we chose a certain surface site and why we did not go 300 or 400 meters south, east, or west. We have put in place an artificial intelligence powered chatbot that works with that limits its information to documents that are only supplied by the study group and which are released for information. We have a phone hotline also. This is important because the project is already active since about now almost 3 years, with field investigations, so where test drillings are taking place, also seismic investigations are taking place. So there has been also information meetings, interactive actually, also with the population. So not only we made frontal presentations in public meetings, but we went also in all of the municipalities that potentially were affected or will be affected by the project with different sessions. And we engaged actually in permanences in the municipalities. So where we spent an afternoon and we engaged with the people, we let families come up. They could tell us what is their worries or what are we doing, what is particle physics, what is this future circular collider. We have to understand, for instance, also that in the Haute-Savoie department, the name of CERN is almost not known at all. CERN is internationally maybe very well recognized and known, but not necessarily at regional level. CERN is known in the immediate vicinity in Switzerland, in Meran, and maybe a little bit in the department, in the department of Laon, and maybe in Geneva in some places, but in the Haute-Savoie region, really, it is not known what CERN is. So this was also an ambassador activity to explain to people not only the FCC, but also to tell them that CERN exists, how long it exists already in the region, what it has contributed to the region, and what are potential risks or what non-risks that are related to this organization. So this is where we are currently. So we have informed about the FCC. We have collected certain feedback information to be able to develop the implementation scenario. And now we are going into the public debate phase that in the end can inform a council decision in the year about 28 or something like that. Coming to the next chapter, that is the inventory now of the environmental stakes, the detailed inventory. So for this, actually, subsurface investigations are already taking place. They look at geological layers, faults, seismic activity, strategic water layers, not everywhere across the entire ring, but first in high risk zones or in zones, let's put it like that, where we have a lack of subsurface information. So this has started with geotechnical investigations and with seismic investigations, and it will be reinforced now also in the next phase, where at a much higher rate, such kind of investigations have to take place to mitigate potentially also certain risks of the civil constructions and environmental pollution risks also. So subsurface water tables were looked by us, seismic activities in the two countries. We looked at terrain, constructed spaces, forest, agriculture, also surface swelling, for instance. Landslides were also an aspect. We had to discard several different surface site locations and ring scenarios simply because the terrain was unstable. Also, flooding is another aspect that is important here for us. We looked at the surface water tables, protection of these waters, and then, of course, everything that has to do with nature and landscape constraints. Very important are the wetlands and the protected water tables, but also the visibility and the co-visibility, the noise levels. Here are some examples of protection zones that we had to look into. Biodiversity index is another thing that we included in our analysis. We looked also at the technical and urbanistic constraints, railways, highways, waterways. Motorways are in particular important because if we have surface sites where we have tunnel boring machines, where we have a lot of excavated materials, it's best if we are placed close by to a motorway. I should note that in France, the motorway system is under a monopoly, so you cannot simply access the motorway. It is a rather tricky and lengthy procedure. So we have early on engaged the work with an organization in France that is directly attached to the ministry in charge of the motorways, and we have checked if there is the feasibility administratively and technically for certain areas to access the motorways, and now actually the motorway design and authorization is already in process. We looked also at the high voltage lines, so the grid supply lines, the 400 kilovolt lines, which is again under monopoly in France, assigned again to an organization called RTE that is linked to a ministry. Also here we engaged very on a feasibility analysis, and now actually we went into an agreement with the RTÖ to go together in the public consultation phase, because they will have to build also the connection to the 400 kilovolt line. They will also have to make environmental impact assessments with us together, but it's CERN, the project owner, that has to compile all this information and present it to the authorities for project permitting. Other interesting things that we looked at are gasoducts, so gas pipelines, petrol pipelines. There are some strategic infrastructures also that had to be included, so they had to be avoided. So we had to gain access to the locations of such strategic infrastructures. Landscape protection zones, noise and light pollution. Light pollution is in particular something very interesting, because if you have an 8 years or 10 years construction site, 24 hours per day going on, you have, especially in the rural areas where we have here quite some impact on the bats. The bats are many of the bats are protected species, so this disturbs actually the habitat and the of the bats quite a lot. So this is an aspect not to be underestimated at all. So the mitigation measures, of course, have not yet been developed, because the impacts have not yet been fully quantified, but at least we know already that light pollution is an aspect, and we know the zones where we have the environmental stakes of bat pollution, bat populations. So now in the next phase, actually the required measures can be developed. Electricity lines I mentioned. So this in the end brought us to a whole map of areas here indicated in red, where it was very clear for us we could not go anywhere there, and some blue colored bubbles here that turned out to be the residual ones where we could fit in surface sites, and that determined in the end also the placement and the size of the ring. So since 2023, these field campaigns are ongoing. They slowed down a little bit last year with the European Strategy for Particle Physics update process, but they are now being revamped again, because now we are going in the next phase where everything has to be analyzed much more in detail, and also the validity of the field investigations, especially the one that concern the biosphere, have only a limited validity. So every 2 years or so you need to update the data. So in reality, this is now a continuous process that will be ongoing until the construction and potentially also further ahead. So here you see a screenshot of such kind of field investigations. So we have a geographical information system where all the observations are detailed, and where the sensitivity grid is also updated with a greater detail, and that permits us now also to plan better the construction activities and the surface site designs. When we do these field investigations, we don't carry them out with the same level of detail everywhere. That would be too much. So, but we define different parameters. We have what we call a ZIP, that is an internal parameter where we do very detailed investigations of the environment, even figuring out how many people are living in a house nearby, counting the bats, recording the noise, counting the flowers and the animals that we see, counting also the traffic. But then we have other areas that, like an onion, are more in the outer shells. And as we go into the outer shells that expand up to a radius about 5 kilometers, we have only a very sparse information. You see an example here in the bottom that is, for instance, visibility and co-visibility. So we explored that up to a distance of 5 kilometers. So far between 2023 and the end of 2025, we have analyzed, together with external consultants, 600 hectares of terrain. I have indicated here to them where these areas are in the current surface site areas. So 600 hectares, that corresponds approximately to the center of Geneva. And in the next phase, this will have to be redone and even further explored. Primary challenge here across, again, the border is that, yes, we have a certain sensitivity grid, we have a prioritization of the different environmental stakes, but the value that is underneath these stakes is different in France and in Switzerland. The methodologies even to analyze this is different. So if you're talking about noise sensitivity, for instance, we have to understand that in France, the noise sensitivity is a relative measure. decibels with respect to a background noise. That is different, of course, during working hours, holidays, evenings, and weekends. In Switzerland, however, the noise sensitivity is indicated in absolute decibel terms. So what is yellow and orange and red is not the same in each country. And then we have a borderline in between them. But the animals don't stop at the borderline. Okay, so the frogs are migrating, of course, across those. And what is protected in one country is all of a sudden maybe not anymore protected in the other country. So this is, for instance, something that now in this current phase that we're engaging in, the cadrage préalable, has to be resolved with the authorities in the both countries. An agreement has to be achieved with them, in which way, for instance, to deal with such kind of with transborder aspects. Water tables under subsurface water tables is, for instance, is another important topic, especially in the area here where we live near to the Lake Geneva. We have water tables that expand quite a bit into nearby France, and the protection status of these water tables is completely different. So the 4-season fauna and flora inventory has been carried out and is entered in our database. We have done also soil analysis. This is important to determine the necessity for the compensation for the use of agricultural space, also the possibility to transplant actually the subsurface, to quantify the economic loss over a time period of 35 years, for instance. It is also important to understand, for instance, if the soil is polluted, because if it's PFAS polluted or dioxin polluted, and today even the space is used as an agricultural space, it probably does not make much sense to transplant it and use it for agriculture again. Probably it's better to even understand that the soil is polluted and then actually do something else with it, okay? Wetland identification is a very important point, because wetlands do not count where they are entered in the database, they count where they are really existing. So we must be sure that we are not unnecessarily destroying wetlands, because this is a natural capital that is very difficult to reconstruct. So this is one of the major constraints of our surface sites, is to avoid that we affect wetlands, or actually where we have degraded wetlands also in the vicinity already, that we plan already for compensation action, that in the nearby areas of the surface site, we integrate these degraded wetlands and we make nature protection zones in combination with our surface sites. So this is a good example where the research infrastructure actually can bring in some added and additional value. We also did the forest analysis, air and climate measurements, water quality measurement, not fully exhaustive, so this comes in detail in the next phase. Background noise measurements, which is very important, because in France we have this relative scheme of the noise sensitivity. I mentioned already landscape and patrimony, not only on land, but also in the lake. So this is a major impact factor there that has to be taken into consideration. And all this information, for all this information, we have set up in what we call an environmental information system, which is based on a geographical information system to which the project members and also the authorities have access to. We create their summary maps that can inform not only our colleagues but also the authorities, and some of the maps are even publicly available. So these are summary maps, so they inform the public about our findings. So here is a screenshot of all of the different layers that we have in such a system, and we manage the data here in a quality assured way. So we have developed forms when companies enter data in the system, that the data is always structured in the same way, annotated in the same way, with the same metadata. So we have developed together with the consultancy company a scheme to uniformize and harmonize these data entry activities. So from the land plot evaluation, we have today a certain margin. It depends on how you evaluate the loss of the land, either officially or market value. So the span is between 4 to 8 million euros in total for all of the surface site land that we need. The agricultural study revealed that over some 30 years, we have a total of about 8 million of economic loss that would be induced by the consumption of agricultural space. Forest, actually, we are able quite to avoid quite a bit. So the loss here is rather modest in the order of 125,000 euro equivalent. These figures help then actually to develop compensation value. It's not necessarily that this money has to be donated or given to somebody, but it gives you an idea then if we have to develop compensation measures, in which order these compensation measures would have to be developed. We have done site and road access studies, also for railway accesses. The electricity I've mentioned has been done already. I said something about the interactive maps and the observation already. Here you have a more artistic visualization on how we present this then to the authorities. There are 2 volumes for environmental reports that have been created. One, we call it the environmental diagnostics, which is really an initial state report that shows how the environment where the project is embedded looks today. It also has an introduction, a high-level introduction for non-technical readers into the project with the motivation, the rationale, the methodology that is behind it. And it also gives an outlook, how would the environment evolve without an FCC over a time period of the next 30 years or so. And then we have a report that we call more the environmental aspects, which is a systematic collection of the technical infrastructures and particle accelerator elements, describing them, and where we know it already indicate what potential environmental effects they could have. So this is like water consumption, electricity consumption, certain metals, rubber, plastics that are used, gases that are potentially emitted, with where we know it's some envelope quantities. And this is a report that is, of course, still under progress because not all of the technical elements have yet been defined. In terms of documentation, we have the possibility to produce PDF documents from LaTeX sources, but a few thousand pages actually if you printed them. We never print them. On the other hand, we have a web-based system where the same LaTeX information in combination with interactive graphics, maps, videos, audio recordings can also be produced on a interactive web page, and it permits the authorities also to log in and see, for instance, only the things with tags that are relating to Switzerland or only those elements that relate to France, or both of them actually. Good. We studied sustainability aspects in addition to the environmental aspects. We carried out life cycle analysis, assessment for the construction, using also again localized products. So we saw quite a difference if we use EcoInvent, for instance, as a generic database, or if we use environmental product declarations of certain concrete that we are able to source here from France and Switzerland, or metals that we can source here in the vicinity of the European Union. So this can make quite a factor of 2 very rapidly. So this shows how important it is that the environmental impact assessments and the optimizations are always done in the localized, geolocalized context. The generic context is good to understand where are the drivers, but the authorities in the end demand from us the very specific project implementation. So this is why we did this. We made studies on the electricity consumption, the water consumption, the land surface needs, and we continuously reduce them also and continue to reduce where it is needed. We made studies also with external partners on the possibility to have waste heat supply. It is demand-based, so we have a generic map of what are the potentials, but then in some of the areas we really went nearby. Here's an example of a cheese producer that is very close to one of the surface sites. It's just 250 meters away, and we engaged with this cheese producer and we figured out how many gigawatt of heat actually this cheese producer would need. They are heating today actually with gas. With gas boilers, so they could substitute in the future these gas boilers with the waste heat to a certain extent of the FCC. So these are studies that are of course ongoing, but these are synergy potentials. These are not yet developed synergies, but it is potentials. The next step will then have to go into more details to make this something concrete. Excavated materials is actually the major concern of the people here in the area and also of the local authorities. There is more than 16.5 million tons of excavated materials that would be produced. However, it would be produced over 8 to 10 years of construction. This makes about 8 million cubic meters of excavated materials, and the majority, over 90%, is what is called molasse material. This is a heterogeneous sedimentary rock for which actually no industrial reutilization existed so far, which is why in 2018 I launched an international competition to find ways with consortia of industrial partners and academia to develop reuse cases at laboratory scale. Now we are going beyond laboratory scale. We're bringing this now from TRL 3.4 to TRL 6.7. One of the solutions is that we produce functional soil from the molasse. The functional soil can then be used, for instance, when you fill up a quarry at a certain layer, you can bring in this functional soil and then amend it with topsoil and regreen quarries, wastelands, brown lands. You can do raised hedges, for instance. You can also use it nearby highways, motorways, or roads. To avoid any confusion, the primary use is not to use it for agricultural purposes. This is something that today, from the authorities' perspective, is not really permitted yet. It still falls maybe under the concept of techno-soil, so it's a bit particular, but nevertheless, the first step is already to produce a functional soil, which we can reuse at least elsewhere to a certain extent, and it would be about 2 million cubic meters out of the 8, for which we have already found candidates where this functional soil could be used. For this, we put up a field pilot at CERN of 1 hectare of land nearby the CMS experiment at 0.5 in CC. This project is called Open Skylab. It is now also co-funded by a European Union Horizon Europe project. It's an international collaboration by itself. And the goal here is to come to a standard operating procedure for a certain plant-soil combination that can then be certified for use both in France and in Switzerland with the authorization partners. We have developed also high-level eco-design approaches, strategic guidelines that the subsystem designers should take into consideration when they are now entering a pre-TDR or technical design report phase. And this is published also in Zenodo. I give you the link here. You will see it's very lightweight. It gives it aims really at creating a bit of a culture of an eco design already, and then of course it would be complemented by the guidance of specialized experts. But at the first level, it's important that the engineers who are designing the accelerators and the detectors gain already an understanding that eco design is something that is important to follow, and the earlier you bring it in, the easier it is actually to work with it. So with this, I come now to the conclusions of my presentation or seminar. That is, I would like to remind that this kind of studies that I've shown you, in which in the end will have to be carried out for any large-scale future research infrastructure project, requires substantial amounts of time, resources, and personnel, and therefore it has to be anticipated in the planning. So before taking a decision to create a new research infrastructure or to make a significant extension to a research infrastructure, one should always keep in mind that the environmental authorizations, at least in Europe, is something that is time-consuming, and it requires also the engagement of the public. And not necessarily the worries of the public are the same worries as the one of the engineers. So actually a culture of mutual understanding also needs to be established. And as it is with all human communication, listening and understanding takes time, and it only works if it's honest and not a fake process, if you wish. Okay. The authorization processes are iterative. It is not possible to understand everything immediately in the beginning. It's clear the authorities understand also that certain details of the project are only known at a later stage. Also, the technological progress should actually be included in the optimization of the process. So if a project development takes like 15, 20 years, it is clear that you do not want in the beginning already to freeze everything and to code everything in an environmental impact assessment, but leave the room open here for the optimization and leverage the technological process also that is coming with the time that passes. It requires a dedicated project management structure with clear definition of interfaces to the external world. So this was clearly a learning exercise in the FCC, which is also why from now, January onwards, at CERN, the FCC project is restructured to make it clearer to the external stakeholders with whom they are actually engaging and interacting and for which purpose, and who is mandated to give a certain information and what is the credibility of a certain information that is provided. In the research field, we have the tendency to publish everything, to be extremely transparent and open, which is really good. But the public often misunderstands this openness. If they go on Google, if they go on Indico and they find presentations by people done, I personally experienced it also, and colleagues else also, that this information is taken as a frozen design. And this creates irritation, this creates suspicion, and this creates barriers. So it takes an enormous amount of time to explain to these people that what they find in PowerPoint presentation of conferences and workshops is not a final design, but this is how science works. This is how engineers exchange ideas in a transparent and open way. So open science is good on one side, but sometimes it can also be a limiting factor if it is not made clearly understood to the public how we in science are working. Another aspect is that the initial state analysis or the environmental diagnostic has only a limited validity of time. So it needs to be repeated continuously. And this is something that has to be kept in mind also in the budget. So if I have to spend 3-4 million on environmental diagnostics every 2 to 3 years, well, this is something that has to be coded in the project preparation budget from the beginning onwards to avoid bad surprises. And finally, the big challenge here is that we are in a transnational context and we have to harmonize and align the two legal frameworks in France and in Switzerland. Thank you.
Wonderful. Thank you so much, Johannes. That was a fantastic overview and in-depth too. So not just an overview.
A bit dense, maybe.
Yeah, no, we can really see how much work has gone into all of this. So thank you for sharing that all.
Welcome.
I already see some hands up in the audience, but I cannot see them on my screen. So if someone would like to go ahead and start asking their questions, please go ahead. I think I maybe saw Raki. Or maybe that was a reaction with a...
It was a clap, and I think
there was a clap,
and then it went down.
Thank you very much.
Okay. Okay, well, this is now a open discussion session for questions, and Johannes has kindly cleared some time for us if we want to stay and discuss. So I don't see any hands up at this moment in time. So I guess I'll kick it off because I did have one first question. So you talked about your approach of the avoid, reduce, compensate quite early on in your talk. But I was wondering, at what point did you decide, or what was your baseline for FCC to be able to decide how much of your initial impacts could actually realistically be avoided? Because, you know, you could easily say, oh, hey, look, we're going to build this thing. It's going to cost us, I don't know, 200 megatons of carbon. And then say a few years later, look, we've reduced it down 99% because we're amazing. So at what point did you say it was realistic, I guess?
Okay. The whole thing, so I've started in December 2013 on the FCC. Okay, so I was there on day 0. And this is an advantage because I knew already from the beginning onwards what would be, I don't want to say what is feasible or not feasible, but where are the limits. So already from the beginning onwards in the first designs, there were some margin conditions that were built into it. Okay, then actually we had first studied in the conceptual design report until 2015, 16 or so. And I went with a French organization, government associated organization, and they made by themselves a preliminary, very rapid evaluation of what we presented as an implementation scenario. And they came immediately back with the feedback saying, look, guys, what you're doing here is not going to work. And this was actually the trigger to go more in a systematic, iterative design. So it was not like that we did something and now we say, oh, we reduced by so and so much and we are so great. So there was really, I have to say, a risk that we could never also make it work. Okay. I do not know what would have happened then. Probably the FCC would have stopped. I do not know. Yeah. But actually the feedback from these government agencies was very good and very helpful, because they pushed us into the direction and they said, look, guys, you should avoid these spaces. You should make sure that the transport ways are not longer than so and so forth. So we did not start with nothing. We started already the optimizing process with guidelines. So this was helpful. Yeah. The carbon story is, okay, the host states require a demonstration of the compatibility with their climate protection plans. Yeah? It could have turned out that the amounts of the carbon that come out of the life cycle assessment would have been prohibitive. I can't tell you what would we have done then, but the amounts are not prohibitive. So that is good. I mean, there is always room for optimization, and we continue to optimize. You've seen, if you take from the eco invent the figure, and then you say, good, but if I buy specific products on the market, recycled steel and so forth, where can I go? Or if I reduce from 12 surface sites to 8, I have less concrete that I have to pour into. Where do I go? The figures are in line with the regulatory frameworks and guidelines. Other construction projects produce many more environmental effects and have much higher impacts onto the climate. The research infrastructure, I was a bit astonished myself, I have to say. I didn't know what to expect. Is rather in line what the government regulatory frameworks prescribe to us. So I don't know. Were we lucky? Maybe. You need a bit of luck sometimes.
Definitely. Thank you. I see, Sarah, you've got your hand up. Please go ahead.
Yeah, I was wondering if the regulations and the position of the governments have changed much over the last 10 years or so. Yeah.
So actually, you hit the point. So we had about 30 scenario candidates already developed in the area in a circumference between 95, 96 to 98 kilometers with 12 surface sites. So somewhere during this process in France, a new law came up for the protection of I don't know how you call it. This is this specific earth. You have it also in the north of Scotland. I think I don't know how it's.
Or
how is it called?
Is it peat?
Yeah, peat. Thank you, peatlands. So, and all of a sudden, I lost about I don't know how many 100 hectares of potential area I lost. I can look it up, okay? It was a few hundred hectares. And the whole class of implementation scenarios in the 96 to 98 kilometer range broke down. So this could have really threatened the FCC. So I went back to the beam optics designers of both Lepton and Hadron Collider, and I said to the guys, guys, unfortunately, we have to change plan. We can't continue like that. Where can we go with a smaller, how much is it acceptable to have a smaller ring? How much smaller can it be? What can we do with the different symmetry? Can we have a different number of surface sites? So this is where then actually the scenarios in the range of 89 kilometer to 93 kilometer with 8 surface sites and a 4-fold symmetry came up. So yes, these regulations, the changes of regulations changed in both countries, by the way, in France and in Switzerland. And again, we were lucky that in the end we presented a scenario now which seems to be stable and where we are no longer threatened currently.
Okay, thank you.
By the way, it's a legal obligation of a project owner to continuously observe the legislation. So this is a nasty thing because it's not the authorities come to you and tell you that they change. You discover sometimes. So for instance, one of the things that is discovered at the border crossing between France and Switzerland in one area was they made subsurface investigations, and the Swiss all of a sudden entered a certain area and say there is a temporary subsurface water table at -25 to -30 meters. And it would have again potentially endangered the project. We were really not sure until about 1.5 years ago or so when we started with our own subsurface investigation, and we were able to confirm actually that it was a hypothesis. They made a modeling of the subsurface, and in the end there is no temporary water table where it was indicated. Okay. But it's difficult to live for 1.5 years in this uncertainty.
Yeah, definitely. So does that mean you're just constantly checking on all of the documentation as you go?
Yes.
Wow, okay. Are there any other questions from the audience? Can't see any hands up. Oh, wait, yes, Raki, please go ahead.
I have a fairly naive question. In your consideration of sites, your initial planning, was there any thought given to the possibility of building the FCC away from the CERN site?
Yes, very good question. Actually, this is not even a thought that we ourselves wanted to spend time on. It is required by law and regulatory compliance. You must present in France and in Switzerland project alternative scenarios and variants. So we had to look also in locations that were further away, though not totally far away, because we are CERN, of course, and our argument is that the FCC should be built here because we have infrastructures that we leverage, and therefore it is more efficient to do it here. But we looked into racetrack scenarios, for instance, not completely circular scenarios that would have expanded a bit into the canton of Vaud in Switzerland. By the way, about a very similar trace that what the Click Accelerator has been looking at, but they never did really territorial investigations. So we found then out this would have been totally prohibitive because we fall here into UNESCO protected environments. We go into an area where we would have to cross the lake that has a depth of definitely more than 100 meters. On the other side of the lake, we would have popped up in an area where the mountains are very high, and we would have come back into highly populated urbanistic zones, so not possible. Then we looked also on the other side of the Jura mountain, so this would have given us the opportunity to not go so deep, so the ring would have been like just 60 meters deep or something like that. But the Jura, on the other side of the Jura mountain, we have a sort of a plain, but then again, other mountains start up. So the area that was available would have not really given us the opportunity to have a particle accelerator much larger than maybe 60, 70 kilometers in circumference. And in addition, it is a natural park. Plus, we would have to have built a transfer tunnel through the Jura mountain, and that would have been really cost prohibitive on one side, and also we have karst geology there, so with high pressure water ingress, so the project realization implementation risk would also have been prohibitive. Then we looked also if we could have the ring a bit further towards the Lyon area, but no suitable, we could not find a suitable location. And even going further down into the pre-Alps, I looked also into that. I could also not find suitable solutions because simply there isn't even any accessibility. So the mountain roads are very winding, very narrow, go high up, high down. So very quickly we understood with the government agencies, they would never allow us to build any new roads there or to enlarge the existing roads. So we had to discard that. But these scenarios are described in the environmental initial state report to the authorities. And eventually this would also be put in a summary form in the documents that will be published during the environmental evaluation process.
Thanks.
Brilliant, thank you. Are there any other questions from the audience? If not, I do have one final one. So you did touch on the immense costs financially of doing all of these studies, all of this work, and the potential for that in the future. I guess my question is, what is the FCC and CERN going to be able to commit to and want to commit to over the, many years that FCC plans to run for? Like, is it going to be doing regular updates of LCAs? Like, so for example, within I guess you have the technical design, etc.
Yeah.
Are you going to be publishing LCAs for the whole facility? Are you going to be doing it for certain components of the actual accelerator itself, etc.?
Super good question. And super difficult to answer. So, in principle, the authorities require us to report on the climate effects. So we will have to continue the life cycle assessments. But as you know yourself very well, also the difficulty is to have reliable designs of the machines, to have reliable assumptions on the materials and the manufacturing prescriptions. And this we do not have for the particle accelerators, and we do not have for the detectors. So what I have engaged last year is life cycle assessment of the technical infrastructures. I don't want to say that it's simple, but it's doable with electrical transformers and cooling and pipelines. But already for the cryo plants, we struggle. So this is something where we need a bit of a creativity. So making sub-life cycle analysis, for instance, of cryo plants, personally, I find this very challenging. It's very complicated. Now, we also have to understand that these life cycle analyses do not have to be super exacto. So one of the approaches that could be taken, but I'm happy to discuss also with you because maybe you have some nice ideas, would be also to lean on existing LCAs or existing products and see how can we maybe scale it up or derive rules on scaling such that we can come to thresholds where we can say, okay, we are probably not going to exceed this carbon footprint with it. The other thing is the iterativeness. So in France, it is understood that we can only deliver certain results when we have certain level of detail of design. And in the French regulatory framework, it is foreseen so that we will have to deliver more and more of this kind of assessments. And there is not one point in time that says, okay, the project is approved and you do what you want. So we know it will be a continuous improvement effort already today. This has changed simply over the last 20, 30 years or so. In Switzerland, we have a bit of a difficulty. In Switzerland, the environmental impact assessment is not based on a continuous improvement. It is based on the demonstration of the compliance of what you would like to build with the regulatory frameworks and laws. So that means you have to come in principle with very detailed design plans. And if you are going to make any change, you have to present the changes in your plan, and you have to come up with new calculations and justify those. And of course, they have to be then smaller than what you have presented originally. So here we have the two challenges. The first challenge is we are not even today able to make the first designs and plans and the first life cycle assessment of a detector or of a certain accelerator. And then in the future, because we have seen it here at CERN with some constructions, making a change in plans and redoing calculations is an extraordinarily time-intensive and cost-intensive activity. So this is something where now we have to go in this cadrage préalable with the two host states and achieve an agreement on how we deal with it, that we are still compliant with the Swiss legal framework, but on the other side, that we have a mutual understanding that CERN cannot deliver already in the next 2 or 3 years the detailed plans and the detailed LCAs of the scientific instruments that are to be built in. But happy to discuss with you and colleagues on how we're going to address that in the future. Yeah, there is room for research and development.
Wonderful, thank you. Yeah, it's a definitely an ongoing and evolving problem for everyone, I think, that one. Okay, I'll just double with the audience. Is there any more questions? Oh, yeah, I see one hand up from Raki. Please go ahead.
It was clear from your presentation how challenging it is to stay abreast and stay in line with the legal requirements from the host states, particularly. How much impact on the planning did not sort of legal requirements, sort of voluntary pledges, say, I don't know, the nationally determined contribution pledges for GHG emissions of your host states impact the planning?
Okay, that is a super good question, and I think I cannot answer it yet because we are not yet officially in the phase where we engage this what is called the environment evaluation. So this up to now, all of the activities taking place were under the sole responsibility of carrying out a feasibility study that we give to the scientific community to make up their mind if they would like to continue with an FCC or not. And now we enter in another phase. Now actually we come to the point exactly that you mentioned. How will the regulatory frameworks impact the planning? And the only thing I can tell you today is that two companies have been engaged contractually to perform, one company to perform a high-level planning for the authorization process, and another company has been now engaged to perform the really detailed environmental evaluation planning, and then these two plans have to be fit together. And today I cannot give you an answer what is coming out of this plan, because we have not yet today a full understanding of all of the detailed studies that have to be carried out. Okay, so stay tuned for more news.
Okay, thank you. We'll be keeping an eye out for that then. Incidentally, where would this be published?
Well, that is a part of the decision-making process, I guess,
Okay.
that the CERN Council. So it's a deliverable of the next phase of the FCC study to the Council in the famous 2028-29 timeframe. And I hope it supports an informed decision making process. Yeah, it's an input that then the member states and associated states and also the host states have to say, yes, we fund later, whatever. Yeah.
Yeah. Okay. And is there anything to be said about the so obviously there, again, high financial costs of implementing all of these sustainability studies, but there's also opportunity for financial savings. through optimization, reducing electricity. Also as the cement industry continues to decarbonize, like it might not be more expensive. It actually might be cheaper. Especially on the time scale of FCC, it's possible.
Yes.
Do you foresee any of that? Have you done any studies?
So this is, I think I said it on slide 3, 4 or something like that. This is this concept of the overall project sustainability. So everything has to be looked at, the 3 dimensions, the society, the environment, and the economy, and then we have to fold it together. So the approach that we do is this, so the economists calls it a wider socioeconomic analysis, where you do not only take socioeconomic benefits on one side and project cost, capital, and operation cost, but you also include the environmental cost. So because this is how an economist works. An economist quantifies and then converts it into a monetary unit. Okay, that does not mean that you have to pay it, but there is a way to convert it into units so that you can sum it up also with capex and opex. And then you have also environmental benefits that you can also quantify and monetize, and then you can put the 2 together and you see what comes out. We have just to be very careful in doing that, because there is this argument of weak sustainability versus strong sustainability. Some natural capital simply cannot be replaced. If I destroy a wetland, I cannot reconstruct the wetland, because the wetland is created by having under subsurface water that comes into an area. The composition of the soil is of a certain type. The water stacks there, and this creates a certain ground for certain plants to grow and for certain animals to live in. So we can quantify in monetary terms what it means to destroy 1 hectare of wetland, but we cannot now say this wetland is maybe worth €1 million, and now I'm creating forest for €1 million elsewhere, and that compensates for my loss of wetland. That is strong sustainability. That does not work. So this has to be considered. We can use cost-benefit analysis, but we have to use it intelligently. We cannot use it agnostic in what we destroy. Okay, so this is work to be done over the next few years.
Yes, definitely, of course. Okay, are there any other or further questions from the audience? I have another one from Rocky. Please go ahead.
I figured since no one else was putting their hands up, I would ask all my questions. I hope that's okay. So I have a very detailed question about something that just sort of struck me as being super interesting. This project that you mentioned about conversion of morass to soil. I've never heard of anything like that done before. What kind of yield of soil do you get, and how much sort of processing or how much energy input is required to get that yield?
So you're perfectly right. You've never heard of this before. It's really new. It's novel. And we're very happy, actually, that we found a consortium who found a way to do that. So the process is, the first material has to be pre-treated. Okay, you have to crush it, you have to sieve it, you have to clean it. So there is work engaged with that. And then the problem is that you have to create a stable matrix that has organic material in it, because there is no organic material in the morass, okay, especially if you dig it up from 400 or 500 meters deep ground. So you mix the material actually with the compost, and sometimes also with the material that is called biopile, which is a byproduct of oil extraction. And then you have sort of pioneer plants that grow rapidly and that help to bind nitrogen and to take carbon dioxide out of the air, and bind again carbon in the soil. So this process has been developed in a collaboration of small enterprises who are in this field, and the University of Applied Life Sciences in Vienna in Austria, and it works. I didn't put photos in the slides, but you may go to the website of Open Sky Lab, just Google it, and you may find photos there. Or from FCC Week last year in Vienna, I made also a presentation there. You should see how the plants are growing. But what now is the importance is not to demonstrate that it works. We know it works, but we have to have it long-term stable. The problem of technosoils is what the experts tells me. I'm not an expert in that, but they tell me you have quickly growing something, but then when rain is pouring in or when you have the soil drying out, the stability of the soil is not there. So we have now what they are mainly doing now is to develop methods on making this long-term sustainable. So treating the soil, for instance, not so much with mechanically heavy instruments, so not with tractors and this kind of things, but have a more soft treatment so that this matrix remains not compacted. So soil compaction is a problem. And now the EU project develops an artificial intelligence-driven soil plant model. And the soil plant model will analyze over now 2-3 years on how the soil plant system is evolving and derive rules from there on which treatment is better and which is less good. So we have individual cells on this Open Sky Lab that are treated in different ways, mechanically also, but also with different plants over multiple seasons. And this is how the experts now try to figure out what is the best way to do it. And this ends up in a prescription, which is then called a standard operating procedure for a specific soil plant combination to achieve this long-term stability. So the good news of this thing is there is a huge area in Europe, north of the Alps, from the Geneva Basin, over south of Germany, into over Austria, down to Hungary, where we have this molasse in very large quantities, also not very deep. So if this standard operation procedure can be certified, and if the soil is stable, there is actually quite some demand of companies to offer that for other construction processes. So these are the good news. So this is how then socioeconomic impact can be generated from the research infrastructure. But if you would like then to know more details, send me an email and I can bring you in contact with the soil scientists.
Thank you.
Wonderful, thank you. Are there any more questions? Okay, well, thank you so much, Johannes. I've just shared the link to the Indico in the
fantastic.
chat. And I will be uploading the recording as soon as I can. I'll just end the recording now, actually.